Wow, time to celebrate. We're down to the last two problems. Here we go. So, what do we have? We have a f prime of x as selected values. What must be true about this? So let's hit these one by one. Concave up. To be concave up, that means what? You should all know that implies that the second derivative must be positive. What does it mean if the second derivative is positive? That means the first derivative must be increasing. Well, if you look from 1 for negative 2 to 0, f prime actually decreases, and from 5 to 6, f prime decreases. Therefore, it cannot be concave up on that whole region. It has to be decreasing at some point. So therefore, false. Let's look at more stuff here. Let's look at C. F is increasing. What does that imply? That tells us that f prime must be positive. Now, looking at the table, it looks like, hey, 3, 1, 4, 7, 5, those are all positive. Here's the problem. You don't know what happens between 3 and 1. It's possible it drops down, maybe let's say at negative 1, it could have went to negative 5. You don't know. You don't know what's happening between. And between these 2 points here, how do you know it didn't go to negative 100? 1 down to negative 100, back up to 4. You don't know what's happening, so you can't assume that. And the key word, what must be true, not might be. So clearly, that doesn't have to be true. Could be, but doesn't have to be. All right, so the same logic goes for this, no critical points. So critical point is where the derivative is 0 undefined. So for the same logic as we used to the prior problem, we don't know what's happening between those points. We don't know if the derivative actually equals 0 between these points. So this could be true, but we don't know for sure. So we're down to BC. The graph has at least 2 points of inflection, or it has at least 2 relative extrema. So let's delve deeper into this. So let's look here. We know, let me see. Okay, here's a key thing. Polynomial functions, all derivatives exist. The first derivative exists, the second derivative, it has all derivatives existing. And so this means all the derivatives exist. And if the derivative exists, that means f and all of its derivatives are continuous. So if we have continuity and differentiability, we know that the mean value theorem applies. So here's what we're going to do. I'll do it in purple. We're going to look at these two and find f prime at 0 minus f prime at negative 2 over 0 minus negative 2. And that's going to be 0 minus negative 2. Oh, whoa. No. I don't know how to math. It's going to be 1 minus 3 over 2, which is negative 1. So what does this mean? The mean value theorem guarantees that the second derivative has to equal -1 in that region. All right, let's look at another pair. Whoa, not what I wanted. Let's look at these two. So, same thing, by the mean value theorem, there's got to be a point between 0 and 3 where the second derivative equals this. So that's going to be 4 minus 1 over 3, which is 1. Let's do another pair, these two. So the mean value theorem guarantees us that at some point between 3 and 5, the second derivative has to equal this, which will be 7 minus 4 over 2, which is 3/2. And then I have one more region to look at. Between these 2 points, the mean value theorem guarantees that the derivative will be f at 6 minus f at 5 over 6 minus 5, which is 5 minus 7 over 1, which is -2. So what do we have here? You'll notice that the derivative, second derivative, is negative here, and it's positive here. So therefore, at some point between those two, using the actual intermediate value theorem, the derivative, well, not using intermediate value theorem, the derivative had to, second derivative had to change from negative to positive. It had to change signs. That's at least one inflection point. And then similarly, between these two, the second derivative had to change from positive to negative there. So it had to have at least 2 inflection points. Bing, 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 bing. The relative extrema, to have 2 relative extrema, you would have to be having 2 places where the derivative changes signs, and we don't have that. We don't know. It could happen, but all of our data, they're always positive. So, bam. We are done. Hope this was helpful. I'll talk to you guys later.